Let's take a look at some exponents. So when we're working with exponents, we're talking about a number with that small number written up top. And it's important to understand how that works, because a lot of times I find students mistake it for just mistake the multiplication that we use in working with exponents as just a short form of multiplication. So you want to make sure you really understand what exponents are. So we'll kind of see that as we work through these different examples of some of our common exponent rules. They aren't necessarily needed to be memorized, but if you do remember them, then it makes things a lot easier, but you can easily calculate them out by expanding things. But we'll take a look here. So we're working with some variables in our definitions here. So we're using a as our base variable. So that's the number on the main number that we're working with. And then that superscript number, that number up at the top corner, is going to be our exponents. We're using things like m and m for those. So in our first few cases here, we're looking at multiplication and division. When we're multiplying exponents together with the same base, so again, it has to be the same base, a and a, it can't be a and b, but with the same base of a and a, we're able to add those together. And we can look at an example here. So we have 3 squared times 3 to the power of 4. Well, 3 squared, remembering that that number right here means we multiply those numbers together that many times. So we multiply 3 together 2 times. So it's 3 times 3. And I'm just using a mathematical dot there. That means the same thing as multiplication. So we have 3 times 3 times 3 times 3 times 3 times 3. So here's our 3 to the 2. There's our 3 to the 4. Well, we have 3 times 3 times 3 times 3 times 3 times 3. That's 1, 2, 3, 4, 5, 6. That is the same as 3 to the 6, which is 2 plus 4 in the exponent. So when we're multiplying the exponents, it works out very well like that. And we can simplify that down, and it works the same whether we're using numbers here or letters. And so if we were to take the next one here, where we're doing division, opposite of multiplication, does something very similar and subtracts those exponents. So in our case here, we have 4 times 4 times 4 times 4 times 4 times 4. So I got 6 4s. I'm just going to write the division like with the division bar. And then we have 4 times 4 times 4. So that's still division, is 4 to the power of 6 divided by 4 to the power of 3. When we're dividing those, we're able to cancel these out, and that's why I wrote them up like this, is so we can just show that cancellation. They both have a common factor of 4 there. That has a common factor of 4. That has a common factor of 4. And thus, those all cancel out. We're just left with a 1 on the bottom, because we can't have 0. We can't divide by 0. It doesn't become 0. When we cancel those out, there's still a 1 there. So we have 1, and then we have 4 times 4 times 4. So 4 times 4 times 4 is 4 to the power of 3. We don't have to put the over 1, because anything divided by 1 is just itself, so it becomes redundant. But again, that 4 to the power of 3 is 6 minus 3. So while you could calculate these out, it does save time if you can just quickly jump from here to here without having to do that middle step. Now when we get to the case of exponent to an exponent, so we have 5 to the power of 2, raise that to the power of 2. So that's actually 5 squared times 5 squared. But 5 squared is 5 times 5, and 5 squared is 5 times 5. So there we have 5 times 5 times 5 times 5, or 5 to the power of 4, which happens to be 2 times 2. So when we have a power to a power, we're going to multiply those exponents together. And there's our example. Now, in the case of fractions, here I have 4 over 3 squared. It just means what you can do is that you can actually spread that exponent over both numbers. So if you had to calculate that out, you got 4 over 3 times 4 over 3. That's the same as 4 times 4 over 3 times 3, which is 4 squared over 3 squared. So just a way to break that over that. Sometimes there's cases where this will be useful when we're working with some of our algebraic equations. Another important one to note is if we have anything to the power of 0. Anything to the power of 0 is 0. When we have 3 squared, it means we have 3 times 3. So if we had 3 to the power of 1, it would just be a single 3. So to the power of 0 means we write it no times. But we have to have some sort of value there. We can't just have an empty space. So we need to put something there. So our value in this case is 0. So anything to the power of 0 is 0. Be it A, be it 5, whatever you want, it's all 0. Now, it's important to note that we cannot combine these terms together. So here we're combining these into one. You cannot combine these together if you have a plus or minus. So that plus minus just means plus or minus. Both cases are there. So if we had an example, say 3 squared plus 3 to the 4, that will not work. We have 3 times 3 plus 3 times 3 times 3 times 3. Well, we can't just say, well, that's 3 to the power of 6, because we're not multiplying those out. Right there we have that addition sign, so it's still that, and those are separated by that addition sign, so those can't be combined. And the same is true if we're subtracting. If we change that to a subtraction, that equation stays the same. It's still separated by that minus sign. And again, this also works with variables like we have over here. So if we had x to the power of 2 times x to the power of 3, well, x to the power of 2 means x times x. And x to the power of 3 means x, so there's our times, x, so there's our power of 2, x times x times x, there's our power of 3. So power of 2 times the power of 3, we have 5 of them, so that is x to the power of 5. And so that still works. And again, even with the 0 value, it still stays as 0. So if you can try and remember these, keep these in the back of your head when you're working. It'll make things a lot easier. Especially note this one, anything with the power of 0 is 0, and be able to do these quickly, again, will make your math lessons a lot easier to do.